Throughout history, human beings have peered into the night sky and recorded the glowing lights that flicker and move above our heads. The first maps of the stars and the planets were drawn on the walls of caves, recorded as calendars and tracked with astronomical symbols. Then books and written records became the main source of information that expressed the way the people of that time thought of the cosmos. As technology, along with our understanding of the universe, became ever more sophisticated, more and more worlds in our solar system were discovered, and with that came the possibility of life beyond Earth. On the face of it, the galaxy looks to be eerily silent. We have not detected any signs of life as of yet. However, the search for life beyond Earth is really only just getting started. Even within our solar system, it is now thought to be a possibility that life could have independently sprouted up in a few different places. You're watching V101 Space. My name's Rob, and if you enjoy my videos, then remember to subscribe and tap the notification bell to never miss an upload. Orbiting the magnificent gas giant planet, Jupiter, is the mysterious icy moon Europa, a seemingly frozen world about the same size as our moon. With a surface temperature of about minus 160 degrees Celsius and a location that means it has to withstand a relentless pummeling of radiation, at first sight it would be easy to think of Europa as a barren ball of ice. But despite the harsh conditions it exists within, this fractured moon is one of the most promising places to search for alien life. So how could life survive on such an extreme moon? And if it does exist, what might it look like? Many spacecraft have passed by Europa during their missions, but it was NASA's Galileo spacecraft that elevated our understanding of this icy moon to a new level. It discovered the first solid evidence that an enormous ocean exists beneath its surface. An ocean with possibly 2 or 3 times as much water as all of Earth's combined. Arriving at the Jovian system in December 1995 with the aim of exploring Jupiter and its large moons, Galileo passed by Europa multiple times, coming as close as 201 kilometers above its frigid surface. It captured its frozen terrain in incredible detail, allowing us to see close-ups of its cracks, ridges, and jumbled up landscape, but also find intriguing evidence of what might be happening below its crust. Galileo confirmed that Europa was geologically active. Its close-up images revealed the enormous cracks in the moon's surface had separated, and dark, icy material had flowed into the open gaps. As with the spacecraft that came before it, Galileo also found only a handful of impact craters, which are expected to build up over time as the surface is constantly bombarded by meteorites over billions of years, much like our own moon, for example. But Europa is smooth, suggesting that its surface is relatively young and that something had erased any large craters, such as icy volcanic flows. One of the most important measurements made by the Galileo mission, however, showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within the icy moon by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that appear to show huge plumes of water vapor erupting from Europa's south pole, although unfortunately they are not high resolution enough to be definitive. But if Europa's surface is frozen solid, then how could a massive ocean of salty water form? And if there is liquid water down there, could life have really started in such a bizarre environment? While the icy shell of Europa is clearly frozen as hard as rock, The interior is warmer because it is heated by what's called tidal flexing. The side of Europa that is closest to Jupiter experiences a stronger pull than the other side, stretching the entire moon back and forth, probably causing the long cracks that run across its icy surface, as well as heating the interior through friction. Similar to how repeatedly bending a paperclip generates heat, for example. It is this constant flexing that melts the internal ice and creates Europa's enormous ocean. But is it really possible for life to start on a frigid moon hundreds of millions of kilometers away from the sun? Well, life as we know it seems to have four main requirements: liquid water, certain chemical elements, an energy source, and of course, time. We have already discovered that Europa may have an enormous ocean of liquid water that is protected below its crust. And certain studies of the ocean have suggested that it may have formed just a few 100,000 years after the moon formed, which is estimated to be around 4.5 billion years old, giving life, if it does exist there, plenty of time to get going. But what about the other two requirements? Chemical elements and an energy source. Chemical elements are the building blocks of life as we know it, and they include carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements are common throughout the universe and make up 98% of living matter on Earth by combining to form organic molecules essential to life. Scientists think these elements were likely present during the formation of Europa, and may have even been added to later on when asteroids and comets collided with the icy moon. One good example of chemical elements discovered on Europa was made fairly recently when the James Webb Space Telescope detected large amounts of carbon dioxide on its surface, as can be seen in this incredible infrared image. Europa is shown as blue, while the carbon is white, and it is thought that it likely originated from the ocean below. Then we need an energy source. All life as we know it requires it to survive. Here on Earth, life relies mainly on the sun for energy, such as through photosynthesis. Plants convert sunlight into energy, allowing them to grow, and that energy is then transferred to those who eat the plants. But any life that may exist in the ocean of Europa is hidden below the thick ice. No light can penetrate through it, meaning that a process like photosynthesis couldn't work. Instead, life would have to be powered purely by chemical reactions. And these reactions could come in multiple ways, such as from Jupiter's powerful radiation that is bombarding Europa's surface, or perhaps more likely from the warm rock at the sea floor. As the icy moon orbits around Jupiter, its interior flexes, as we have already discovered. The flexing forces energy into the moon's interior, which then seeps out as heat. The more the moon's interior flexes, the more heat is generated. If Europa's rocky ocean floor is heated by tidal flexing, that process could potentially be supplying energy in the form of available chemical nutrients in hydrothermal vents. And this type of process can be seen here on Earth, where life is abundant. The vents are like bubbling cauldrons of energy, spewing out superhot water that has flowed below the Earth's surface, becoming heated by a layer of molten magma. They erupt with plumes of what looks like smoke bellowing out of a chimney, but within it is a soup of chemicals that certain life can thrive on. The chemicals would be toxic to human beings, but these organisms can convert the chemicals to energy. This process is called chemosynthesis, and is what ultimately powers entire ecosystems around hydrothermal vents found in the deep dark regions of our oceans, the places where the sun's light cannot reach. The vents are the only places on Earth, in fact, where the ultimate source of energy for life is not sunlight, but the Earth itself. Huge red-tipped tube worms, ghostly fish, strange shrimp with eyes on their backs, and other unique species thrive in these extreme deep ocean ecosystems. So life as we know it on Europa, it seems, could be possible. But what might it look like? To get an idea, one place we could look is within one of the deepest, darkest points on Earth, the Mariana Trench. The deepest point in the Mariana Trench is called the Challenger Deep and is 11 kilometers below sea level. It is difficult to comprehend how deep that actually is, but if you placed Mount Everest there, the peak of the mountain would still be more than 2,000 meters below sea level. However, that's nothing when compared to Europa's ocean, which is anywhere between 60 and 160 kilometers deep. But despite this enormous difference in depth, the conditions between the two environments may still share some similarities. Imagine a vast, seemingly endless, pitch-black void filled with crushingly cold seawater. This is the type of oppressive environment life within the Mariana Trench has had to adapt to. But dive deep enough and you will find some of the weirdest creatures on Earth. Creatures so strange that you would think they were from Europa. Take the snailfish for example, a species that breaks the record for any living vertebrate. It is the deepest living fish ever discovered, found at more than 8,000 meters below sea level. This weird, translucent, tadpole-looking fish is known to contain chemicals which help keep its membranes and cell walls flexible so that the crushing pressure doesn't kill them. But there are creatures that live deeper. Within the deepest region of the Mariana Trench, the Challenger Deep, 3 organisms are most commonly found. The first are called xenophyrophores and are the world's largest single-celled organisms that resemble spherical or frilly sponges about 20 centimeters across. It is unsure exactly how these weird creatures survive, but it is thought that they produce slime that soaks up microbes from the sediment around them. Then there are anthropods, which are shrimp-like scavengers that survive the deep seas because of exoskeletons that contain aluminium. How these little creatures find this metal is a mystery, but scientists think they use sugar-based chemicals in their guts to extract aluminium ions from the sea floor as they feed on debris raining down from above. The third are called holothurians, which are a species of deep-sea sea cucumber. They are the most alien of the known animals in this region and are highly diverse, appearing with spiky, brightly coloured skin or smooth, translucent skin. Vast fields of sea cucumbers have been discovered at the bottom of the Mariana Trench, like cows grazing over pastures as they feed on bacteria and decomposing matter on the sea floor. So if life has managed to thrive in the deepest oceans of Earth, could it have also done the same in the even deeper oceans of Europa? Until we send a probe capable of drilling through the thick layer of ice that encases it, we may never know. Europa could be full of alien creatures, or it could be completely barren. However, that burning question may be answered in the next few years, because the European Space Agency, along with NASA, each have 2 separate major missions to Europa. The first, from ESA, is called JUICE, and has already launched in April 2023, arriving in 2031 with a double flyby with the aim of collecting new data on the chemistry of the icy moon. Then we have NASA's Europa Clipper, which is a mission designed to determine once and for all whether this icy moon's ocean is habitable or not. It is scheduled to launch in October 2024, but won't arrive until April 2030. The exciting missions should complement each other, but neither will be able to confirm if aliens exist there, just whether the icy moon has the right conditions to support life as we know it. If we did eventually find some form of life on Europa, it would probably be in the form of microbes, surviving around a hydrothermal vent. But if it can be demonstrated that life formed independently in two places around the same star, regardless of how complex it is, it would then be reasonable to suggest that life springs up fairly easily once the necessary ingredients are present. And one of the first places where we may find those ingredients is the shrouded moon Titan. This is Titan, a moon larger than the planet Mercury that is orbiting the ringed world Saturn. It is a moon that has captivated the imaginations of scientists for decades, because below all that thick cloud, vast seas, lakes, and rivers have been discovered pouring over parts of its frozen surface. This is the only place in the solar system other than Earth where liquid flows across the surface. Titan is a truly mysterious place. Although 4 separate spacecraft have flown by the moon, it still holds many secrets, such as where did its thick atmosphere come from, how did its lakes and seas form, and does it have the potential to harbour life? Large bodies of liquid on Titan had been suspected since the Voyager probes passed by in the early 1980s, but it wasn't until the Cassini spacecraft visited in 2006 that they were actually confirmed. Unlike the oceans of Earth, which are made up of water, it was discovered that the lakes and seas on Titan are made up of liquid methane and ethane. These lakes and seas, which can be seen in these dramatic radar images, are typically located in the polar regions of Titan, and they can be quite large. Some of the largest are comparable to the Great Lakes of North America, for example. Fed by rivers that cut through Titan's frozen landscape, they are also incredibly deep, with some areas estimated to be over 200 meters deep. Although still a mystery, Titan's seas and lakes are thought to have formed from the breakdown of methane and nitrogen in its atmosphere. Over time, these compounds condense into clouds and fall back to the surface as rain or possibly even snow. On Earth, it is mainly life itself that refreshes the methane supply in our atmosphere. Methane is a byproduct of the metabolism of many organisms, and it comes from the simplest of biological sources, such as those associated with peat bogs, rice fields, and animals like cows or sheep. So could the methane on Titan be a sign of life? One thing is for sure, if there is life on Titan, it won't be like anything here on Earth. The lack of liquid water would mean that life as we know it, which relies on water, cannot exist on its surface. Here, it is extremely cold, with temperatures hovering around minus 179 degrees Celsius, making the conditions on this mysterious moon harsh and extremely challenging for living organisms as we know it. But that doesn't mean that life hasn't found a way to thrive on Titan. Some microorganisms on Earth, for example, have been discovered to consume and survive in hydrocarbons, and the lakes on Titan are primarily composed of liquid methane and ethane, which are hydrocarbons. Any life that could exist in these lakes would have to be adapted to living in an environment that is drastically different from Earth's, however. But scientists have hypothesized that Titan life could be based on a completely different biochemistry. Instead of relying on water as a solvent, these life forms could use hydrocarbons such as methane and ethane. This, however, would require a different cell structure for the organisms to survive. Drop any Earth organism into one of Titan's lakes and it wouldn't last long. Even our hardiest single-cell beings are held together by membranes made from fatty molecules called lipids. Lipids hang together and form a barrier because certain parts attract water molecules while other parts repel them. But Titan's lakes have no water to interact with, and the frigid temperatures would freeze any Earth life solid. But another molecule like acrylonitrile might be able to do the same job and survive in Titan's harsh conditions. And incredibly, scientists have found direct evidence of acrylonitrile molecules on Titan. and insufficient quantities to theoretically support millions of single-celled life forms. So it is possible that microorganisms could potentially form the basis of a complex ecosystem on this bizarre moon, possibly with a larger organism feeding on them and so on. However, as exciting as these ideas may be, at this point we don't have enough information to know for sure what kind of life, if any, could exist on Titan. The only probe ever to land on its surface was the Huygens probe back in 2005, which entered Titan's atmosphere and became the first probe to land on a moon in the outer solar system. It captured stunning images as it descended and landed, and continued to transmit data for about 90 minutes after landing. In this incredible surface image, we can see what looks like a dried up, relatively flat, pebble-strewn plain that may have once been covered in flowing liquid methane. But as you can see, there is no indication of life. Although the idea of strange life forms thriving across Titan's surface is certainly an exciting one, the methane in its atmosphere is more likely to be the result of outgassing. When Titan formed, it was probably too hot for volatile compounds like methane and nitrogen to remain on the surface. Instead, these compounds were trapped in the moon's interior. Over time, the heat in Titan's interior began to dissipate, causing the volatile compounds to escape through cracks in its crust. These compounds then combine to form the complex mixture of gases that make up Titan's thick atmosphere that we see today. So, if this is the reason for the abundant amounts of methane found in Titan's atmosphere, and not the result of life swimming through its frigid, flowing lakes, then does that mean that this bizarre moon is sterile? Like most of the solar system, as far as we know, unable to harbour life? Well, possibly not. Observations and measurements by the Cassini spacecraft and the Huygens probe suggest that Titan may have a subsurface ocean of liquid water deep beneath the icy crust of the moon. If there is indeed a vast body of water below Titan's crust, it is possible that life could exist within it. Water is a key ingredient for life as we know it, and the ocean could provide a habitat for life forms adapted to the unique conditions of Titan's environment. However, as with the methane lakes above, the conditions in this subsurface ocean would be very different from those on Earth. The ocean would be extremely cold and would likely contain high concentrations of salts and other dissolved substances, which could affect the ability of any potential life forms to survive. So Titan could potentially harbour environments with conditions suitable for life, meaning both life as we know it and life as we don't know it. Although so far there is no evidence of life on Titan, its complex chemistry and unique environments are certain to make it a destination for continued exploration. One of the most exciting future missions is NASA's Dragonfly mission, which will send a rotorcraft lander to explore the surface of the shrouded moon. Dragonfly is scheduled to launch in 2027, and it will arrive at Titan in 2034. The mission will be based on a rotorcraft lander, similar to the successful Ingenuity craft, which has completed more than 50 flights on Mars. Dragonfly will fly to multiple locations on the surface, including dunes, craters, and the equatorial region, where it will investigate the potential for liquid water and the chemical conditions that could support life. As we continue to explore the outer reaches of our solar system, Titan remains a fascinating destination that holds the potential to revolutionize our understanding of the universe. With its methane lakes and seas, along with a secret subsurface ocean, this enigmatic moon is a world unlike any other. But could there be a planet beyond our solar system where life has flourished, and where we might realistically one day be able to visit? Well, it turns out that planet could well be located right next door. A world similar in size to Earth that is orbiting the closest star to the Sun, Proxima Centauri. And although it is likely being bombarded by radiation from its star, it turns out this neighbouring planet could still be a promising place to search for alien life. The star Proxima Centauri is an odd one by any measure. It is part of a triple star system where the two main stars called Alpha Centauri A and B are roughly sun-sized and orbit one another relatively close by. But Proxima Centauri is a small, long-lived, low-mass, cool-in-temperature red dwarf star that is so dim you can only see it with a powerful telescope. It is, however, the closest of the three, at just 4.2 light-years away from the Sun, and it is where at least 3 exoplanets have been spotted, 2 of which are confirmed and 1 of which is located within the habitable zone of the star. The region where it's not too hot or too cold, where liquid water could exist on its surface. Called Proxima b, it was first detected in 2016, and at the time it created a lot of buzz, mainly because of where it is located around its star, but also because it is roughly the same size and mass as Earth, most likely making it a rocky world. The hope and speculation at the time was that it might have an Earth-like atmosphere, the same raw ingredients and elements as our world, and most excitingly, perhaps even life on the surface. However, as further research was completed, it became clear that Proxima b, although sharing some similarities with Earth, is experiencing a very different path. Because Proxima Centauri is a small red dwarf star, around 14% the diameter of the Sun, it is substantially cooler. This means that despite being within the habitable zone, Proxima b is a lot closer to its star than Earth is to the Sun, over 20 times closer in fact, making 1 year on Proxima b only a mere 11.2 Earth days. You might think that a smaller star would be a calmer star, but that's actually not the case at all. Red dwarfs produce violent solar flares a lot more frequently than the Sun does, because their nuclear fusion cores are much closer to their surface. This makes their surface much more chaotic, resulting in incredibly strong magnetic fields. In turn, those strong magnetic fields can blast intense high-energy radiation into the surrounding system. And because Proxima b orbits so close, it is likely being bombarded with space weather that is far more violent than what we experience here on Earth. Proxima b is also most likely tidally locked in a synchronous rotation, meaning that one side is always facing the star and one side is always facing away, much like our moon, where one side always faces the Earth, for example. On Proxima b, however, this would result in half the planet being bathed in perpetual daylight, while the other half is in a never-ending frozen nighttime. The sun-facing side would be constantly exposed to high levels of radiation, and possibly even blasted with solar flares. In 2021, for example, a gigantic flare around 100 times more powerful than any experienced in our solar system was recorded blasting out of Proxima Centauri, and some scientists think these bright outbursts would slowly eat away at the exoplanet's atmosphere, if it does have one, and wipe out any water that may be on its surface. So, although Proxima b is within the so-called habitable zone, its close orbit to its small star means it might not be very habitable at all. It would need a thick atmosphere and a strong magnetic field that could hold its own against extreme radiation that is up to 500 times more harmful than what we experience on Earth. On the face of it, this type of environment would strip atmospheres, evaporate oceans, and fry DNA on any planet close to a red dwarf. Yet, it turns out that Proxima b might not be a dead world after all. Because Earth climate models are showing that rocky exoplanets around red dwarfs can still be habitable. Scientists using a supercomputer created various climate models in a 3D simulation, revealing what a planet's climate is like based on specific conditions and environmental changes. When they simulated the possible climates on Proxima b, they found that the exoplanet could still be habitable despite being tidally locked, with one side exposed to heavy amounts of radiation. With an atmosphere similar to modern Earth and a strong magnetic field that deflects the extreme radiation it is being bombarded with, Proxima b may well be covered in an ocean that extends to the night side. If seen from space, it might even look like a giant eyeball staring into its star. How much of the planet this ocean covers would depend on the amount of salt in the water, as this would lower its freezing point and allow it to extend into colder regions. But even if it has high salinity, with a thick atmosphere and a strong magnetic field, an ocean is possible according to these simulations. And if the right ingredients are also present, then Proxima b could theoretically host life. If we look at the Earth's Dead Sea, for example, microbial life has found a way to thrive there, despite a salt concentration above 30%. So, it's not impossible for salt-loving life to likewise exist on Proxima b in this scenario. The simulation also revealed that thick clouds on the star side might act as a massive umbrella. This could help to deflect even more of the star's radiation. And with a combination of atmosphere and ocean circulation, warm air and water could move around the planet, transporting heat to the cold side, keeping the atmosphere from freezing and creating regions that maintain liquid water, even though those parts never see light. Of course, although this research is exciting, it doesn't tell us whether or not there actually is any atmosphere or water on Proxima b, or even if it ever had any. But if the exoplanet formed very wet, then there is a possibility that water still persists. It may also have started out further away from its red dwarf star and slowly moved closer, providing protection from powerful flares in its early days. While conditions on Proxima b are certain to be very different from here on Earth, alien life could exist beneath such exotic skies, and they could see a plethora of landscapes, such as frozen wastelands, rugged mountains, parched deserts, or oceans from horizon to horizon. Only time will tell what strange and wondrous forms life might take under the angry glare of its red dwarf star, if it can of course exist there. If Proxima b is suitable for life, then it could also mean that the galaxy is teeming with similar worlds. After all, red dwarf stars are by far the most common in the Milky Way. Scientists think that 20 out of the 30 closest stars to Earth are red dwarfs, meaning that any life living on planets orbiting these dull stars might be the norm, and that maybe we are the really strange aliens. As it stands, however, Proxima b has never even been directly imaged, and the information we have on the elusive exoplanet is very limited, resulting in a lot of speculation. But with powerful telescopes, we will get our first glimpse of this strange world. The James Webb Space Telescope might be able to detect an atmosphere, and there are even plans for tiny swarms of laser beam pushed probes to be sent to the Proxima Centauri system, possibly arriving there by 2075, a journey that would take humans aboard a ship several thousands of years to achieve. But the most exciting way we might soon be able to see Proxima b is via a new ground-based telescope called the Giant Magellan Telescope, which according to its website will be one of the most powerful ever built on Earth, yielding a resolution 4 times greater than the James Webb Telescope. It is still under construction and is estimated to receive its first light in 2029, but when it does, researchers predict we will be able to see Proxima b for the first time, possibly even receive a brief film of it orbiting its star, and even take spectra of the planet to look for biosignatures in any atmosphere it might have. So the future is looking exciting when it comes to our closest exoplanet neighbour. Within the next few years, we may finally be able to answer the question, pushing aside once and for all any speculation of whether Proxima b really is a world capable of life, or whether it is just a sterile rock we should finally look beyond. I really hope you enjoyed this video. If you did, then please tap the like button and subscribe. Thank you for watching, and I'll see you next time.